Failure is the vanguard of success. The avenues of endeavour herald discovery. But this path has no end. Space is infinite. The questions are limitless. In a million years hence, we will still look up and ponder what is above and beyond.
Coming up in this edition, in 1983, the America's Cup was won by the Australians. The US needed an edge, and they got it with a combination of NASA technology, 3M manufacturing, and a component that was inspired by a rather unlikely contributor. Wildfires are responsible for the destruction of many thousands of hectares of forest. So why are crews from the Los Angeles County Fire Department actually setting this area of the San Gabriel Mountains ablaze? And this week we continue on NASA's mission STS-103, a daring project in which 7 astronauts chase, capture, service and repair and then return to orbit a space telescope that has dramatically expanded astronomers' understanding of the cosmos. To create a yacht that could win back the America's Cup for the United States was an achievement realised by Dennis Conner, a winning team, and the boat, Stars and Stripes, on February the 4th, 1987. Many enthusiasts felt that the loss of the America's Cup 4 years earlier to the Australians was due to a failure to keep up with the latest technology. In an effort to ensure that the Americans had the fastest boat, many changes were made. The design team, led by John Marshall, elected to make use of a new type of drag reduction technology called riblets, developed by NASA's Langley Research Center and manufactured by the 3M company. These sheets of thin vinyl plastic placed on the underside of Stars and Stripes are actually grooved with microscopic scratches called riblets that form perfect triangular peaks and valleys running the entire length of the boat. The boat itself looks a little like the Space Shuttle in the sense that the surface is paved with separate plaques of riblet material. Rather than having a potentially smooth surface, this is an intentionally rough surface. By placing a small section of the 3M film under the microscope, it's easy to see the riblets and their triangular grooves. The idea of riblets came out of research to modify aircraft so that they move through the air with less resistance. The same researchers found that some sharks have riblet-like skin that allows them to glide effortlessly through the water. Only the fast sharks have this type of skin. The slow ones do not. It was engineer Mike Walsh who originated research into riblets at Langley. The microscopic V-grooves were first studied on machined aluminium plates in this low-speed wind tunnel. 3M then developed a way to put the riblets on vinyl. Test samples of the riblet film were flown to the Boeing Aircraft Company and aboard a NASA jet to confirm its efficiency. The reduction of skin friction by riblets is about 6 to 8%. And that transfers directly into savings by the airline industry of roughly $300 million a year. Since it's lighter than paint, it's being considered as an alternative protective coating for aeroplanes. Questions are still to be answered regarding the efficacy of riblets, but they are being considered as coatings for natural gas pipelines, submarines and race cars. NASA riblet technology. a high-tech solution that helps keep America on a competitive edge. Every year, thousands of acres of Southern California forests are wiped out by wildfires. That's why it was so surprising to see crews from the Los Angeles County Fire Department actually setting a blaze in the San Gabriel Mountains. Using a ground-based device called a TerraTorch and a helitorch dropping gelid gasoline from above, almost 1,000 acres of chaparral forest were ignited. The goal was to prevent a larger, potentially catastrophic wildfire in this area of heavy, dead vegetation. But the control burn also served another purpose. It gave numerous scientific groups, including 2 from NASA, an opportunity to study the impact of fires on our environment. Of primary concern is the effect of large-scale burning on our atmosphere. Evidence points to the fact that gases are building up and the environment is changing. Burning off biomass, forest vegetation, shrubs and grass is a very important source of a number of these gases that have important environmental impacts. One significant gas produced by burning vegetation is carbon dioxide. Computer models suggest that if the level of carbon dioxide in the atmosphere is doubled, the average temperature of the Earth will go up 3 to 4 degrees. The result could be extensive melting of the North and South poles, causing widespread flooding around the coastal areas of the world. Agricultural growing patterns could also be dramatically changed. Crops now harvested in the central US, for example, might only grow in Canada. To determine how much carbon dioxide and other so-called greenhouse gases were coming off the burn, a Langley researcher working aboard a helicopter flew through the smoke plume collecting samples. These samples were analysed at the NASA Center. Looking at natural fires from a different angle, 65,000 feet above, is another group of scientists at the Ames Research Center in Mountain View, California. The key to their effort is a U-2 high-altitude aircraft equipped with a sophisticated picture-taking device called a multispectral scanner. From imagery generated by the airborne scanner during the fire, significant characteristics of the blaze can be determined, such as temperatures and dynamics of the smoke plume. Langley's data is used as the basic information. Then the data from the Ames remotely sensed data is overlaid on top of that in the hope that we can predict, not only on a local basis, but from a regional and global basis, what impact large-scale burning is having on our environment. This week, we rejoin mission STS-103, a special project of America's National Aeronautics and Space Administration, NASA. Mission STS-103 saw 7 astronauts launched from the Kennedy Space Center in Florida during the final days of the 20th century. Their task? To pursue the Hubble Space Telescope, secure it to their Space Shuttle Discovery, and by means of 3 spacewalks, carry out vital servicing and maintenance of the remarkable telescope. Deployed nearly 10 years before this mission, the Hubble Space Telescope, or HST as it's often referred to by the astronauts and mission controllers, is a giant observatory aboard a spacecraft. It can make observations of the universe using visible, near-ultraviolet and near-infrared light spectra above the filtering effect of Earth's atmosphere. Because of its ability to capture faint light in fine detail and the precision of its observations, the Hubble Space Telescope rapidly expanded astronomers' understanding of the cosmos. But like most intricate pieces of man-made machinery, the Hubble needs regular attention. The STS-103 mission marked the third visit by a space shuttle crew to the HST. Here, on the sixth day of the mission, the Hubble telescope is scheduled to receive its final upgrades as astronaut Steve Smith, the free-floating spaceman, and John Grunsfeld, on the end of the remote manipulator system, or robotic arm, perform the last of 3 planned spacewalks to refurbish the orbiting observatory. Their planned 7.5-hour-long spacewalk will see Smith and Grunsfeld install a transmitter that relays Hubble's scientific data from the telescope to the ground, and an upgraded digital recorder replacing an older mechanical version. The transmitter to be installed replaces one that failed 12 months before. Since that time, the second onboard transmitter had successfully carried the load without any disruption to Hubble operations. The transmitters are considered very reliable and, unlike most of the equipment aboard Hubble, were not designed to be changed out in orbit. So special tools were developed to enable astronauts to do the job more easily. Smith and Grunsfeld also installed a solid-state digital recorder, replacing an older mechanical reel-to-reel recorder version. The digital solid-state recorder provides more than 10 times the storage capacity of the old unit. Also on Smith and Grunsfeld's schedule, the application of some new insulation on equipment bay doors to minimize any degradation of the telescope's protective thermal coverings. Both the transmitter and the recorder checked out normally on early tests by telescope controllers. The earlier spacewalks of this mission, on each of the 2 previous days, had completed the highest priority tasks. Those tasks included installation of 6 new gyroscopes and 6 voltage temperature improvement kits, giving Hubble a new computer 20 times faster and with 6 times the memory of the old computer. Another key task that had been completed was the replacement of one of Hubble's 3 fine guidance sensors. The second of those walks lasted 8 hours and 8 minutes, ending at 9:25 p.m., making it the 4th longest in history. Part of the reason for the length of the spacewalk was difficulty in hooking Grunsfeld's suit up to orbiter power after he had returned to Discovery's airlock. This walk brought the total time of STS-103 extravehicular activity to 24 hours, 33 minutes. This mission's 3 spacewalks bring the total amount of time spent servicing Hubble to 93 hours, 13 minutes. In all, Space Shuttle program spacewalks had now totaled 317 hours and 3 minutes. And this walk also took STS-103 payload commander Steve Smith into the record books as the astronaut with the second longest combined spacewalk time, with 35 hours, 33 minutes, behind only Jerry Ross with 44 hours, 11 minutes. After the successful completion of those tasks, lead flight director Linda Hum announced that the STS-103 mission had met all criteria for complete success. The Discovery astronauts are scheduled to release Hubble a little before 5 p.m. Central Standard Time on the following day, Christmas Day. The final Christmas Day of the 20th century began with the Hubble Space Telescope still secured to the payload bay of the Space Shuttle Discovery. But it was no holiday for the crew of the STS-103 mission. On board the flight deck, Steve Smith in the foreground was conducting video documentation of the solar arrays attached to the Hubble. He was joined by pilot Scott Kelly, who was making his first flight into space. About 1:45 p.m. it was time to perform the major task scheduled for the day: to return the Hubble Space Telescope to orbit, allowing it to continue its astronomical observations. European Space Agency mission specialist Jean-Francois Clairvoy manoeuvred the mechanical robotic arm, provided to NASA by the Canadian Space Agency, towards the huge telescope anchored to Discovery. Clairvoy then managed to firmly grasp the HST before gently lifting it out of the support structure. A series of computer commands disconnected the Hubble from external power and confirmed its readiness for release. The telescope's aperture doors were commanded to open, and at 4:50 p.m. Clairvoy released the upgraded telescope. Mission Commander Kurt Brown fired Discovery's steering jets to begin separating from the telescope. The telescope's redeployment took place at an altitude of 370 statute miles as the two spacecraft flew over the South Pacific's Coral Sea, northeast of Australia. 30 minutes later, ground controllers at the Space Telescope Operations Control Center in Maryland were reporting that the telescope was in normal operating mode. With the HST now back in orbit, each of the 7 astronauts on board broadcast back to Earth holiday wishes from space in several languages. The message from Mission Commander Kurt Brown was particularly appropriate as the end of the millennium approached. He said, "The familiar Christmas story reminds us that for millennia, people of many faiths and cultures have looked to the skies and studied the stars and planets in their search for a deeper understanding of life and for greater wisdom. We, the Discovery crew, and this mission to the Hubble Space Telescope are very proud to be part of this ongoing search beyond ourselves. We hope and trust that the lessons the universe has to teach us will speak to the yearning that we know is in human hearts everywhere, the yearning for peace on Earth and goodwill among all the human family." On the following day, with their primary mission objectives successfully completed, Discovery's astronauts began preparing their spacecraft for its scheduled return to Earth. High on the list was checking out the flight control system and reaction control jets that support re-entry. STS-103 Commander Kurt Brown, along with pilot Scott Kelly, first performed checks on the flight control system by activating one of the 3 auxiliary power units aboard Discovery to allow them to test the various aero surfaces that will be used to steer the shuttle once it has re-entered the atmosphere. The crew then did a check of the reaction control system, the maneuvering jets that steer Discovery while the shuttle is in space. Both the FCS and RCS checkouts were without issue, with all systems ready to support Discovery's return to Earth. Later in the day, the astronauts began stowing the equipment they had used during the past week and started to button down Discovery's on-orbit systems. The Ku-band antenna, which provided most of the capacity for data and television relay, was stowed late in the day. As the STS-103 mission winds down, the newly refurbished Hubble Space Telescope slowly moves through its checkout sequence prior to resuming scientific operations. The HST was now separating from Discovery at the rate of about 5 miles per 90-minute orbit. All that remains for STS-103 is a safe return, and Entry Flight Director Wayne Hale advises there is a very good weather forecast at both possible landing sites for the next 3 days.
Plan for tomorrow's entry, we are going to be bringing up both Entry and KNC. Right now the forecast that we're looking at has both sides go, both for intermittent and +1 and +2. There is a concern about the cost of the
The final day of mission STS-103. After waving off the first landing opportunity of the day because of a concern with crosswinds at the landing site, the crew was given a go to perform the deorbit burn, which came at 4:48 p.m. Central Standard Time and caused Discovery to fall out of its 380 statute-mile-high orbit to start the journey home to the Kennedy Space Center. These pictures just pick up Discovery as she's 20 miles from the runway at an altitude of 36,000 feet. Commander Kurt Brown reports that he has the landing field in sight. The next step will be a maneuver to set up the final approach and landing, with Scott Kelly lowering the landing gear at an altitude of about 300 feet. By comparison, commercial airliners normally lower their undercarriage 2 minutes out from touchdown at an altitude of between 2,000 and 3,000 feet. Pilot Kelly, flight engineer Jean-Francois Clairvoy, and mission specialist Michael Foale joined Brown on the flight deck for entry and landing, whilst mission specialists Steve Smith, John Grunsfeld, and Claude Nicollier were seated down in the middeck. The orbiter is now sinking at a rate of 177 feet per second, with a glide slope of 19 degrees. A commercial airliner would approach with about a 2-degree glide slope. With the landing gear down and locked, the mission is almost over. Discovery touched down at 6:01 p.m. Central Standard Time on runway 33 at the 3-mile-long shuttle landing facility runway at the Kennedy Space Center to complete a mission spanning almost 3.25 million miles. The end of the STS-103 mission marked the 20th consecutive landing at the Florida spaceport and the 13th night landing in the history of the shuttle program. Left behind in orbit, the Hubble Space Telescope, now featuring 6 new gyroscopes, 6 new voltage temperature improvement kits, a new onboard computer, a new solid-state recorder and new data transmitter, a new fine guidance sensor, along with new insulation on parts of the orbiting telescope. Mission STS-103, another successful adventure into space by this 7-man crew that will broaden our knowledge of the further reaches of the universe.